paper is entitled AI Evolutionary Shift from the Cloud to Edge Compute Environments. As the 2023 Technology Recession sets in and global business technology budgets are more constricted, companies are becoming more conscious of projects and platforms that have high ongoing costs, may be less commercially minded, or may even be purely experimental research and development. This has led many to shift their data centers to the cloud over the last decade, and they've realized that their on-premises data centers were much cheaper, had acceptable levels of performance and reliability, and the promises of cloud computing may have failed to deliver the cost savings and hands-off approach the company may have been sold at the onset of the cloud project. The strongest case study we have is that of AI. So in the AI model design, construction, training, and implementation, companies are now facing huge cloud computing bills as they try to implement commercially competitive AI models into their consumer-facing and back-end operational flows. The option to bring high-powered, expensive cloud servers and their associated bills back in-house is something that many companies are beginning to look at with great alacrity. Some of the possible cost savings associated with shifting out of the cloud and moving back on premises include on-premise AI infrastructure. So according to a study by 451 Research, on-premise infrastructure can be up to 70% cheaper than cloud AI infrastructure in the long run. Obviously, this estimate is based on comparison of the cost of running a typical workload over 3 years on premises versus running that workload in the cloud. Now, if you're training a basic AI model, the costs involved in training that model can be $400,000, it can be $44 million, depending on how many factors and parameters and what type of gear you're using, depending on how long it takes, depending on how much concurrent processing you have in play at the time. A second reason is that when you're on site, when you're on premises, you can use open source AI models and software with a lot more freedom. And the cost savings associated with using open source can vary widely depending on specific software and the actual use case. But surveys by Black Duck Software came up and said that companies on average save about 30% on their software costs by relying on open source. So we're talking Linux rather than Windows. We're talking MySQL rather than Oracle. Then the third reason is AI model optimization. So the estimate that optimizing AI models can reduce cloud costs by 30 to 50% comes from a report by Accenture. The report notes that optimizing AI models can reduce the amount of compute resources required to run the models and can in turn reduce cloud costs. A fourth reason is if you take an actual hybrid cloud strategic approach. So the potential cost savings of utilizing a bit of cloud, a bit of your own on-prem, and then merging the two come from a report by Forrester Research. So according to that report, the hybrid strategy can save companies up to 30% over utilizing pure cloud on its own. And they can run appropriate workloads on premises, things like compiling databases, fusing tables for deep data analytics, that type. My research questions were fivefold. So did companies who migrated to the cloud really consider extensively the long-term costs to operational expenditure, OPEX, or merely the short-term savings on CAPEX, outlay? Second question, how were these cloud business cases and projects deemed successful? I also asked my third question, holistic costs are an ongoing concern in all OPEX scenarios. Has cloud scaling been pegged to cash flow, or have people just shifted this idea away from CAPEX and move it to OPEX and just let the OPEX run free? Third question, what are the known risks and corporate hesitancy associated with the major three cloud providers? And then my fifth question is AI expenditure and LLM, so large language model training, causing a shift back to on-premises data centers, which from my intro you can assume that was the core question behind this. So again, the answers that were forthcoming came from core articles across the technology industry, indicating large costs associated with cloud computing. There were multiple industry conversations with CTOs, with solution architects, with founders of large companies that were at the height worth billions of dollars, obviously have come down now, but having those conversations, a lot of them did communicate these astronomical bills of using purely cloud solutions. I did a lot of use case comparison of cloud costs, as edge devices were fed into cloud versus edge devices coming straight across to a private data center. We also looked at the experience risk amongst CTOs. A few factors that did surface, like amongst the big cloud players, where AWS is a competitor to pretty much any retailer out there. So if you're Harvey Norman, or if you're Kmart, or your Target, Amazon gets or AWS gets pure insight into what products are selling and what's not selling, and they can compete and they can do their own labels. Google Cloud Platform, so GCP, have an extremely active depreciation policy. So if you find that you're using some kind of service of theirs, a database, a lookup engine or something, if they don't have 100 million users or they don't have like a lot of usage on a platform, they'll shut it down. And they've done that a few times and companies have been relying on these platforms and had to quickly migrate across to other platforms, and that's just an inherent business flow that Google Cloud works with. Obviously, then we mentioned Microsoft Azure, or Azure, or whatever we call it in Australia. It's very tightly integrated with Active Directory, with 365, but a lot of companies have found that they're very license heavy. So where ordinarily you were used to using Linux and using MySQL, once you shift across to Azure, you end up using like Windows Server and SQL Server and enterprise level versions of those platforms, and a lot of companies have been pulling back because of that. Now, the fifth aspect that we looked at was the compute options, and legacy companies facing very large cloud bills, and they take their lower cloud bills with a focus on shifting back to data center, and they're looking at four things that they're shifting. So non-critical applications, legacy applications, resource-intensive applications, and highly secure applications and data sets. So non-critical, legacy, resource-intensive, and highly secure. And a lot of that has been shifted back to on-prem because they just can't get the throughput, the privacy, the security, whatever they're concerned about. They just can't really get it completely from cloud. So the journey itself started with an article from Basecamp, where 37 Signals, that's their main product, is called Basecamp. They looked at a $7 million a year cloud bill, and they said this is just getting a bit silly. It's really eating into our profitability. And they said if we took exactly the same hardware that we were relying on in the cloud and put it into a co-location or built our own data center, it would cost us $600,000 a year, one tenth of the cost. It was a big awakening for them, and they decided they're going to shift back to the data center. And that got me thinking. I said, and then AI surfaced, and I said, wait a second, AI models have relied on thousands of nodes. Whatever Basecamp is facing, they really must be coming along and saying, oh my God, we're going to be facing these huge astronomical cloud bills by training our models in the cloud. Sure enough, OpenAI had to bring on Microsoft with the Azure servers early on as a direct investment partner, really to enable this access to this compute capacity. Now, was this smart of them? Yeah, sure it was. They got a really big name backer. They got a really big name investor. And sure enough, when it came to scaling, when it came to looking at commercialization and really driving this product to market, Microsoft was right there helping them. So it was a wonderful idea, but costly. AI has brought much efficiency to the workforce. As MIT and Amazon Prime Video demonstrate, upwards of 30% gains in progress on their platforms and utilization efficiency through AI optimization. We then look at FPL, so Florida Power and Light, and they have these large-scale events, like hurricane could come in and wipe out service to 1 million of the 30 million Florida residents, and you have 1 million homes without power. How do they know which homes are actually offline, and how do they know which ones are still live? So every single power meter has a IoT device that is uses a network, and each of them talk to each other till they eventually get to power line posts, and they communicate back to the central data center, which they have a few different locations, but there's one up in about an hour north next to the nuclear reactor. They have one an hour south of me, again next to another nuclear reactor, funnily enough. So Florida is quite nuclear active. And then in Plantation, which is about 15-20 minute drive south of me, they have their main activity center where they monitor what's going on. So when the network started failing, they could actually see clearly on a map that these IoT devices weren't communicating back to the network activity center, and they could see where they had to send the teams out to start fixing things. And had they relied on a purely cloud play for that, it would have gotten very, very expensive very, very quickly. And that was the word actually when I did interview product managers over there. The word back from them was that they had to look at a data center based initial staging environment, and then for heavier processing, shift it to the cloud and do their visual analytics, which they did. So then we see Accenture talking about grid health. We're talking about NVIDIA that is at the forefront of visualization of these edge devices. And I then go on to talk about the actual solutions to overuse of cloud. So auto scaling, security techniques. I talk about dynamic pricing, and then this idea of smaller cloudlets surfaces where you utilize a smaller data center like DigitalOcean or something where you can power up a major machine, whack your data at it, do some processing on that data, and then feed it off to a larger environment that's more suitable to massive scale processing. Again, we talk about I talk about cost optimization and go through what Oracle has on offer, what NVIDIA's cloud. Then I started looking at the Omniverse. So NVIDIA has now become a $1 trillion company, and the Omniverse is very much their 3D playground. So their idea is they've got the digital twin cities, where a city has their entire grid, their entire architecture put into a digital environment. So if different areas of government and architects need to go in and need to look at what's going on, they can use a digital twin, and that is then updated every time something happens in the physical world. And that's becoming a big thing, but obviously the data that's involved in utilizing and ongoing maintenance of such an environment needs to sit inside a data center, because it'll just be preposterous to sit in the cloud. So the nail in the coffin and the conclusion came from Williams and Peterson. Very much, there were papers that came out this year, actually in 2023, and they spoke about energy consumption and allocation strategies that are associated with costs. So when you price out a project that is cloud related, you really need to look at how much energy, how much cost, how much consumption, how much collaboration do we need, and if we have to start moving this data around, the costs are going to escalate really, really quickly, and that was something that has become a major factor now. And as the recession begins as the onslaught of cost saving starts, we're going to see this happening more and more.